So let's get started here. So today I'm going to speak on the topic new performance features in SQL Server 2022. Let's begin. A little bit about me, like I do not want to read any of this because Saranya already introduced me. So yeah, only important thing here is to see like if you have any questions and you are unable to ask me here, and if you are shy to ask me here, definitely, you can contact me on LinkedIn. I'm very active on LinkedIn and Twitter. If you do not have Twitter account, that's fine. I'm on LinkedIn, so you can go ahead and connect to me, and then you can also see what other sessions I'm giving in the future. I do speak a lot in different conferences, so I keep everything posted over there, so you can look. And dbnuggets.com is my website where I usually post about SQL Server and Azure SQL. It's all about like database administrative stuff. So if you would like, you can go ahead and visit there. As a part of agenda, today we are going to see the latest features in SQL Server 2022. And also a couple of features which you are seeing here are already present in SQL Server. They got introduced way before, but then they add improvements to it. For example, SQL Query Store, right? Query Store feature um, is inbuilt with the SQL Server. You do not have to purchase extra, but it's an inbuilt feature which got introduced in SQL Server 2016. But as we move along, as we come like in SQL Server 2022, they add couple of additional features, like for example, SQL Store, SQL Query Store hints. So we are going to talk about that. I'm going to show you a demo about that, and also other improvement features like parameter sensitive plan optimization, also known as PSP optimization, and memory grant feedback, degree of parallelism feedback, and cardinality SP feedback. So before going into the query store hints, if any one of you in the call do not know about this feature, I highly suggest you to turn on this feature, because in SQL Server 2022, query store feature is automatically enabled on any new SQL Server databases. If you create a database, then it will be automatically enabled. So knowing what query store does and how to use it is really important, just to take advantage of it to improve the performance of your queries, to figure out what queries are running slow, right? So we are going to talk about that. And before talking about any of these additional features, I'm also going to talk about some internal stuff, because um, just trying to know what these features does will not help if you do not understand the deep internally what exactly SQL Server will do behind the scenes when it runs a query. So I'm going to talk about a lot of internal stuff today as well. So you will love it, I'm sure, if you are into the internals of SQL Server. So let's get started. So, like I said, before going into the query store feature, let's see what this feature actually do and how it works behind the scenes. So, I know this slide is like really overwhelming to see, but let's go step by step. I will start like from the scratch, like when a query runs on SQL Server. And let's take, for example, um, we have this query store and we enable the query store. One of the advantage of query store is like if you know a query is creating multiple execution plans, and you know that one particular execution plan is like performing really well and the other execution plans are not performing well, and by using the query store, once you enable the query store, right, it is a database level feature. It is not a server level feature. You need to turn the query store on every single database that you would like to gather the information, right? So once you enable the query store, it will go ahead and collect. It's like a monitoring tool, let's say. It will collect the query ID, query text, query plan, and what all indexes are used in that plan, and what are the memory grants it used, or like what is the memory consumption, and what are the CPU memory limit, and all the sort of things, right? IO information. Basically, the resource consumption information will be also captured. And you can see that information within the database query store itself. So once you enable the query store, it will create a different folder within the database known as query store. So you can use the views to view this information. There is internal views on the database. Um, so you can run those views to see that information, or you can also use the graphical user interface. I'll go ahead and show you in our demo how to view that. But why I'm even talking about all of that, right? Because this to understand this slide, you need to know like what are the advantages of the query store. So one of the advantage of query store is it doesn't only collect the information once you enable, but also if you know one of the execution plan is working perfectly fine, but the others are like not performing well, you can go ahead and force that particular execution plan so that the next time any parameter you use on the store procedure, let's say you enable the query store on a database, and one of the store procedure has created like 20 execution plans, and you know one execution plan is working fine, so you force a plan by using the query store. What does it mean when you say like forcing a plan, right? So you are forcing SQL Server to choose that execution plan from next time it runs. So from next time the store procedure runs, no matter what parameter it uses, it will go ahead and take that execution plan no matter what. It will ignore the rest of the execution plan and it will force that execution plan. So what is the advantage of forcing that? Since we know that particular execution plan works amazing, so SQL Server will take that execution plan and it works fine. So most of the time, forcing the plan is beneficial when you have like parameter sensitive um, queries running, like parameter sniffing problem. Like for example, if one parameter in a store procedure is producing like 1 million records, let's say, but rest all the parameters that the store procedure uses only produce like some thousands of records, that means this is an outlier, right? The parameter which produces million records, which gives the million records. So if that um, if the execution plan that got generated for that parameter which gives million records, and SQL Server is using that all the time, then that doesn't benefit because the rest all the parameters are only giving us some thousands of records. So forcing a plan in this type of situations will be really beneficial because it will just ignore this plan which got generated just for that particular parameter, which is an outlier. So, um, so by saying that, let's say we are executing a query here. We enable the query store on a database and we are running a query which we force the plan, let's say, right? So um, we are going to see that how the plan forcing and how the thing will run behind the scenes. But let's say any query, right? Doesn't matter if the query is running for the first time or like if it is using query store or not, any query running on the SQL Server, when it executes, when we try to execute, from the application or from the SQL Server Management Studio, the engine will go ahead and check if the query is running for the first time. Now, if the query is running for the first time, then it will go through the compilation and optimization phases to build the execution plan. Now, if the query is not running for the first time, it will go ahead and check if there is a plan in the plan cache. And if there is no plan in the plan cache, again, you might be thinking why the plan won't be in the plan cache, right? There are several reasons why the plan might be evicted out of the cache. Like, for example, you might be restarting the SQL Server, or there might be a memory pressure on the SQL Server, and all these old unused plans will be evicted out of the cache. So there might be some sort of these scenarios. So it have to go ahead and rebuild the execution plan again. So it will go through the compilation and optimization phases again to build the plan. But what if the plan is already there in the cache? Then all right, it will go ahead and take the plan out of the cache. But before moving forward, now here comes the query store. Now we are talking about a query. Until now, what you have seen, all of these steps will happen no matter if the query have like no matter if we enable the query store or not, right? For every single query. But once you enable the query store, there will be an additional step here that will happen known as check for recompilation. So what it will check during that time is it will go ahead and check the plan that I have taken from the plan cache or the plan that I have created, is it similar to the forced plan? Remember, we forced this plan, right? So it will go ahead and check all the time whether the plan is similar to the forced plan, because these are two different things. The forced plan is saved somewhere, and the plan that got generated or taken from the cache is a different plan. So they will be compared together, and if at all the plan is not the same, there might be the scenario where the plan might be an entirely new plan. For example, you forced a plan, right? And some other DBA or a developer come into the play, and then they will delete a index which is used in that forced plan. Now, what will happen if you modify the objects which are used in that force plan? Now, SQL Server will get confused. Let's say a index which is used in the force plan is dropped. Now, the engine cannot find the index being used in that force plan, so it will think like, huh, this in this particular force plan, I don't see if I can use it because there are the objects are missing within it. So let me ignore that and create a new plan. And the new plan might be entirely different. So it will go ahead and check that. And if the plan is not similar to the force plan, then it will go ahead and apply and force that force plan. Now, um, if the plan is the same, then it will go ahead and move ahead with the next steps. So the next step is before execution. Again, now we are not in the execution phase yet, right? Before execution, the query text and query plan will be saved inside the um, plan store. So when you enable the query store feature on a database, there are a couple of things that will happen behind the scenes automatically, right? So there are a couple of memories that get enabled in the memory, known as plan store and a runtime start store. These two are the memories that will get enabled once you enable the query store. So inside the plan store, the query text and the query plan will be saved in the plan store. Again, this is in the memory, right? And once it saves that, everything, all of this process, like saving the query text and query plan into the plan store, this process will happen asynchronously. Um, Again, asynchronously meaning behind the scenes. While this process is happening, it happens behind the scenes. So after that, the query will go to the execution phase. Now, query have to execute to capture the runtime stats. There is no other way. It can't capture before the execution. So the query have to execute, and it will put these runtime stats that are collected into the runtime stat store. Again, this is in the memory, and these two memories are only enabled when you enable the query store. So again, this process will also happen asynchronously, but one thing that you have to remember is once all of this information is captured in these memories, there is certain limit, like there is certain time limit that you can set where where all this query text, query plan, and runtime stat store will be pushed into the query store schema. Um, that is known as interval. And in that interval, once that interval has hit, then all of this information will be pushed to query store schema. But sometimes mm, there might be a memory pressure on the SQL Server. In that scenario, it can push the data, the collected data, into the query store schema a little bit earlier, before hitting that limit, right? Before hitting that interval limit. So where does this query store schema located? Query store schema is always located in the primary data file of the database. All the information that is being collected about your queries is stored in the primary data file of the database. You cannot change the location. It is by default, and it is a standard to stay there. You cannot change that. So that's how the query store runs behind the scenes. Now you might be thinking, okay, well, good and enough. Like query store is good, but we already have the plan cache, right? If the plan cache will always already It already collects all of this information. Now, why do we need to enable query store? There are a couple of things here. With the plan cache, whenever you restart the SQL Server, all the query plans are evicted out of the cache. You know that. But with the query store, all of this information is captured over time, gathered over time. So, um, it won't be evicted until you set out the cleanup intervals, right? And then with the plan cache, only the latest plans will be stored. But with the query store, again, it's over time. It will capture over time until you hit that cleanup policy. And whenever there is a memory pressure on the SQL Server, the first thing that the SQL engine will do is like it will go ahead and clean up the memory. And in the memory, it will first choose the plan cache. Least recently used plans will be evicted, kicked out of the cache. But in the query store, again, that won't happen until the flush out interval is reached. You remember in that last step that I mentioned in the previous slide, all the captured information will be flushed out to the disk when that interval is hit, when that flush out interval is hit. That's this. So only if you are using the plan cache, it is really difficult to figure out why the plan has changed. Like if at all a plan has changed, like why, what is the reason of the change in the plan, right? But with the query store, all the information is collected. So it is easy to see the previously used execution plan and what is the current used execution plan, why the plan might have changed, what is the difference. You can compare between the plans, all of that. So it is easy to troubleshoot the performance problems. Now, what are the advancements of Query Store in SQL Server 2022? Again, like I mentioned in the beginning of the session, if you are in SQL Server 2022 and if you are creating a new database on SQL Server 2022, Query Store is enabled by default. And if if you are migrating the old versions of SQL Server databases to the newer versions, then that will not make any change. Like it won't turn Query Store automatically on the newer versions, but you need to manually go ahead and um, enable the Query Store on those sort of databases. And the additional advantage in SQL Server 2022 is a query store used to, in previous version, it used to also collect all the ad hoc workloads, and there used to be no limit for those ad hoc workloads. The problem with the ad hoc workloads is each query that you are running from your application, if it is an ad hoc query, it will have an entirely new query ID. For every even the single slightest change in the query, like a space or like a comment or like anything, right? Even a simple space can create an entirely new query ID. Those sort of queries are known as ad hoc queries, and I highly suggest you to compile, like change those ad hoc queries into the stored procedures so that they will only have one query ID instead of um, like filling out your query store with different query IDs, and it will blow up your query store very easily if you use more ad hoc workloads. But with SQL Server 2022, they have changed the internal limit. They have created a limit of how much space in the memory can these ad hoc workloads can use. Once that ad hoc workloads limit has reached, it won't capture any of additional ad hoc workloads. But previously, as there was no limit, ad hoc workloads will entirely blow up the query store. It will fill up the query store. And what will happen if the query store is filled up? Will it turn it off, or like what will happen, right? So once the query store limit is reached, the size limit is reached, or the memory limit is reached, it will go through the read-only mode automatically. So that's one of the advantage that they have in the query store SQL Server 2022 is to set these limits automatically. It's an internal memory limit that has been set. The other advantage is query store hints. We are going to talk about that query store hints in the next slide. And the next one is intelligent query processing. Just a minute. Let me see. I will grab some water. I have a cough problem, so if you can give me just 1 minute, I'll be right back, okay? Thank you for waiting. Let me share back my slides again. So before going into intelligent query processing, let's go ahead and see a demo on the query store hints. Uh, I hope you are seeing my slide, my management studio. If you can confirm. Yes, all right. Thank you. So, so we are using AdventureWorks database here. Let me put the database. It is taking a while. Hmm. Okay, let's talk about the next feature. Maybe we can see the demo a little bit later. So let's talk about intelligent query performance, processing features, IQP features. Something going on here. Let me see. Not this one, this one. Okay, this time it should run. Okay, should open. All right. So let's see the query store query hints here. We are using AdventureWorks database, and all I'm doing is like so. Query store hints are similar to the query hints that you use in SQL Server, right? For example, if you do not have a query store enabled on your database and you wanted to use the query hints, this is how you use. I just put here an example of how that will look like, right? Like if, for example, like if you have a parameter sensitive query and that query is using a wrong execution plan, the only way that you can resolve that problem very quick is to um, use like change the code of the query itself by adding this recompile option, like option recompile, and use that hint. Like for example, here we are using query optimizer compatibility level 110, but it can be anything, right? Just an option recompile will go ahead and compile and optimize a different execution plan. So for example, if you have a query that is being run from the application and you are an on-call DBA, suddenly at 3 a.m. in the morning, they might have called you and said like, hey, I don't know what happened, but we are having an outage here. The query has timed out. We don't know what happened. And you just ask them like, okay, open up a ticket. I can look into it. And then they give the query store procedure name and then the database name. You just go ahead and look, and this is the query. This, let's say this is the query, right? So you don't have much options. Like in the middle of the night, whom do you call and to to rewrite the entire code? Like let's say you figure out an issue within the query itself that like developers did a terrible job and they pushed the code into the production. The code itself is not good enough. It is not taking the necessary like indexes or um, something like that, right? The query itself is not that good. Now you can't change the entire code right now. It requires time, and then there might be several approvals that are needed, and vendors might not agree if you have vendors in between, and all sort of things. So um, but we do not have any option, right? Apart from doing a recompile or set the use the query hints or that sort of thing, you need to definitely touch the internal code of the query. But by enabling the query store, right? By enabling the query store, you will see a query store folder. If I refresh here, hmm, I don't like this. Like, huh? I thought of refreshing it, and now it is taking time. Okay, well, good. Okay. See, if you see, once you enable the query store, right, you have this query store folder, and if you expand that query store folder, you have all of these graphical user interface reports that you can use to view the query store. Like, let's say top resource consuming queries, view top resource consuming queries. If you click on that, and you see this graphical view with the bar graphs, which I really don't like. You need to hover your mouse to see the queries itself. So if you want to see the in the grid view format, just click on this grid view where you can see the query ID and then object ID and then the query itself. Like if you observe here, the query text doesn't give you like the create store procedure name and blah, blah, blah. It won't show that, but it will give you the parameterized view. It doesn't give you the entire query and like that. It is always like in the parameterized format. And all of the other information like how much duration it took and what is the execution count on it and what is the plan count, how many plans we have, and all the plans that it generates will show up here, and along with the plan ID. Like if that query ID generates like 10 different plans, let's say the query ID um, E89 will generate like 10 execution plans. All of these execution plans will be showed up here, and at what time and like when was they created, and what is the plan ID for them. And once you click on that, you can see the plan here. You can compare the plans as well. So you can see the metrics as well. If you click on the metrics, you can see the different metrics, on what metrics you can filter out these values, right? And the statistics as well, average, minimum, all of those sort of things. And if you wanted to force a plan, generally what you do is you click on the plan ID, and then you force a plan here. Did you see this force plan? And once you click on that force plan, it will say, do you want to force the plan? And if you click yes, then it will go ahead and give a little tick mark over the that particular query ID. And next time, no matter what parameter you use, it will go ahead and use this particular execution plan. Now, I would like to unforce this plan because I don't know, we are not using this plan, so or the query. So let me unforce it. But the thing is, I forced and unforced the plan by using this graphical user interface, right? So the thing here is, do not do this by using the graphical user interface, because if you do that, then your monitoring tools might not capture that information. You definitely wanted to know who did what. So try to use the store procedures specially designed for the query store, like force the plan, unforce the plan. Use those sort of store procedures designed for the query store to force and unforce. That way, your monitoring tools can capture who executed what query. So So by using this query hints, right, let's execute this simple store procedure. Like I created this store procedure. All I'm doing is I'm dropping if it exists and then creating this store procedure. It is simple select statement if you see, where I'm searching on the product ID. That's it. So I'm executing that. And then I would like to clear out my query store. I want to make sure it is clear. Now, if I refresh, as we cleared everything, it cleared everything here. And I'm also going to clear my procedure cache. So here we just created the store procedure, right? So I'm going to execute these two executions. Now, let me enable the actual execution plan here. Include actual execution plan and execute. Now, if you see the results, the first one, if you see the bottom right, how many results it produced? Like 360,000 records. And the second execution is just 385 rows, if you see here. So there is a huge lot of difference. The first one is 360,000 records. Now let's see the execution plan. The first execution plan that got generated after we created the store procedure, the first ever execution, has chosen to do the clustered index scan because I understand if you see how many records it is trying to read, right? It just gave us 360,000 records. So I understandably this is the right thing to do the clustered index scan. But what about the second one? Second one has just gave us the 360 records or something, but is it really necessary to do the clustered index scan on that? What about the resources, right? So, so this is the general way how SQL Engine will work. The moment that you execute, the moment that you create the store procedure and the first execution that you do, execution that you do, if that parameter is sensitive, like for example, this parameter created 870 parameter created 360,000 records, which did clustered index scan. But the next time it runs, this particular plan that got generated is saved in the plan cache. So the next execution, no matter what parameter you use, it went ahead and used the same execution plan. So that's not right here because most of my parameters just gives me like a couple of hundreds of records. So cluster index seek and a key lookup should be good for me. But what should I do here? Like how do I resolve this issue if I do not have a query store? Now there is no other way apart from me doing the recompile every single time that the query runs because I do not know when this particular execution will happen, right? So is it good? No, it's not because is it really good to do the recompile and touching the underneath code all the time? No. So by using the query store hints, what you can do is you can grab the query ID of this particular query store procedure that you are using by using these sort of this view. All I'm doing is I'm searching on the query text of that store procedure to grab that query ID. So for that query text, I have the query ID 3. So what I will do is I will use this particular store procedure designed for the query store hints. Execute sp query store set hints, use the query ID, which is 3, we just checked. And what we are doing is adding the value of option recompile. Once I execute that, I will go ahead and do the same kind of execution again. And this time, again, the first execution gave me 360,000 records, and the second one is 385 records. But if you see the execution, the first one is clustered index scan, which is good because 360,000 records, right? But the second one is index seek and beautifully it choose an index seek and key lookup because there are only 365 records. And that happened without me changing any underneath code. All I did was I choose the query ID and I used the store procedure to do the recompile. So it will sniff the parameter anytime this particular store procedure runs and it will recompile automatically for you. Now, the advantage is you do not have to touch any underneath code, right? Now, to view the query hints enabled on my database, I will use these views to get that information. For the query ID, the query hint ID is 1 for the query ID 3, and the query text, the hint text is option recompile that we used. So you can get this information, right? Now, what if I would like to use um, another query hint, right? For example, max top 1 on the same query ID 3. Now I will execute that, and then I'll go ahead and clear out my procedure cache. Do not do this in production. This is just my demo, and I want to make sure my demos work. So I did that. So let me execute this executions again. Now in execution, if you see, did you observe something here? The first one did the clustered index scan, and the second one also did clustered index scan. Now, if you see the results, the first one is 360,000, but the second one is still 385. Now, why did it choose clustered index scan? Previously, it did do the index seek and key lookup, right? So, what happened here is it enabled, if you do the properties here, and see, it has enabled the max top 1, but it didn't choose to recompile. Now, why is that? Because you did not append. All you did was replace, right? You did option max top 1. So the moment you write something else, it will just overwrite it. So to append what you are doing, to append the previous option, you have to do like add the previous option recompile and then add the second option that you wanted to use in order for you to um, keep that previous hint that you used. Otherwise, it will go ahead and it will just replace that. So right now I'm enabling both of them. Okay, the query ID, it shouts like query ID is different. So query ID 3. Now, if you go ahead and see what all the query hints options you have, now it will go ahead and say query hint ID 3 on the query ID 3 option is recompile max top 1. Now, did you observe something here? What about the query hint ID 1 and 2? Now they are gone. They are gone from this history. Like when I use this view, it only gave me the latest query hint ID. Now what if I changed completely, like an option I added something else, like for example option use the compatibility level something. The previously like you are a DBA who is actually handling this part, and then there is another DBA who comes along and just change this option. Now, how do you know what was the previous one, right? Because he changed it to the new one. Now, internally from SQL Server views, you cannot get that information, but you have a way to capture the history of the query hints that has been used previously. By using the extended events, you can actually capture that information. Now, I have written a blog post on dbanuggets.com in the query store fundamental series I have. Um, there is a lot of content you can learn from those blogs, but especially I have written a blog post on how you can actually create an extended event to capture these query hints. So go look it out, and you can actually, there is a step-by-step process how to enable, you can see that. Now, since I enabled both of them, right? Now let's see whether both of them will work. Now I am executing again. Now this time, the execution plan it will work wonderfully. The first one will use the clustered index scan. Second one is index seek and key lookup, and whether it used the max top 1. It also used max top set to 1 as well. So in that way, you can actually go ahead and see how many query store hints you can use by using this blog post from Microsoft. You can see all the updated query hints that you can use with the query store. So let me go ahead and share back my slides. So here we are seeing the intelligent query processing features. Um, these features, like all the blue color that you are seeing, are the IQP features added in SQL Server 2022 or the advancements to the previous ones. Um, so let's see each one separately and talk about them. So the highlights here are, if you wanted to use any of these IQP features, all you have to do is make sure your database compatibility mode is in SQL Server 2022, and that will actually take care of all of these IQP features. You do not have to change anything, and these IQP features can work together, not like if one feature is working, the others are in sleep. No, they can work together. And you can see the benefit of like query performance, um, because these features are related to query performance, right? So you'll see the impact on your performance when you move to 2022 and using the latest compatibility mode. Again, the query store advancements, we have talked most of them in the previous slides, but there are a couple of things that we need to talk here. Um, for example, the query store used to not capture the data on your read-only replicas previously, but with the SQL Server 2022, the that information, the read-only replica queries information will be captured on the query store database on the primary replica. So the same channel, the same tunnel that is used to send the data from the primary replica to the secondary read-only replica, the same tunnel will be used again to send the data back from the read-only replica to the primary replica. I mean, query store information, right? All of the information that is captured on the query store read-only replica will be sent it back to the primary replica. But the thing is like it can't capture the information on the read-only replica, of course, because it is a read-only replica, right? You can't write anything to the read-only databases. So so let's talk about the parameter sensitive plan optimization. So parameter sensitive plan optimization is also known as PSP optimization. So if you observe clearly in the previous demo, we talked about the parameter sensitive queries, right? How they work, like if you do not have the query store, how those how the wrong execution plan can be used from the cache for the next executions, and how it will waste the resources on the SQL server, right? So Microsoft has observed this problem of parameter sniffing, and they thought like, okay, what if we not only save one execution plan for the query, but what if we save up to three active execution plans inside the memory, so that based upon what parameter we use, the SQL engine will itself decide which execution plan it can use. So they started saving up to three execution plans per query per store procedure, let's say. So that will actually help reduce the parameter sniffing problem automatically. So how did they do that? Right? There is something known as dispatcher and variant plans that got introduced in SQL Server 2022. Now let's talk about what is this dispatcher and variant plans. So let's say you are sending a parameterized query which have like a sensitive parameters, right? Let's take the previous example. One query, one parameter sent 360,000 records, and the other one is just 385 records. Now, when that particular store procedure executes, now the thing here in SQL Server 2022 is there is something known as dispatcher plan, which will actually have a tree of information. Like let's say you have indexes, right? You know the index tree, how the top layer will actually have the information of where it have to go and what it have to choose, right? In the same way, this dispatcher plan will have the information, the logic of which execution plan it have to use based upon the parameters that is coming in. So let's say if a parameters that is coming in have less than 10,000 records, right? This is just an example. Like we are taking as a um, we are taking the variant. Query variant is nothing but the query itself. Um, so let's say um, here the query variant, which is a query which have agents less than 10,000 listings. So any agent which have less than 10,000 listing, go ahead and use seek and key lookup because that should be it. It is enough. And less amount of resources will be used to do that seek and lookup, seek lookup and a small memory grant should be enough. Now, what if we are sending a parameterized query with a different parameter that have more than 10,000 and 1 million listings, which you are seeing in the um, middle of the screen? It will go ahead and choose. Let's go ahead and create a plan which can do the scan and the medium memory grant. And what if there is a variant, there is a query that is coming in, there is a store procedure that is coming in with a different parameter value, which will generate more than 1 million listings, right? In that case, it will go ahead and do scan plus large memory grant. So that's how it will save maximum of three execution plans based upon the flow of your data within your tables, based upon the skew in your data itself, right? How like um, skew meaning like what kind of parameters are generating how much of data and what values do we have more. Do the parameters generate more of like some hundreds of records or like millions of records or thousands of records. Based upon that, it will analyze and it will generate up to three execution plans, active execution plans. Now let's see a demo on how this will work, right? Um, let's see a demo. Let's close this one. Okay, let's go here. So here in our demo, we are using Stack Overflow 2013 database, and I'm I'm just making sure my query store is turned on because this is a old database, right? I just restored it onto SQL 2022, so it won't automatically enable the query store. Again, the only feature that is not requiring the query store is PSP optimization. So it is good to have the query store on, but it is not necessary for the PSP optimization to have this query store to be turned on. But the thing is, how do you enable the query store um, with the operation mode read, right? Is like I have placed it here and I'll just enable it um, since I wanted to. So I have placed all the options of like how you can actually set up the query store, what parameters you can use and what options you can use. You can see that later. But here I would like to show you how to enable PSP optimization. It is automatically turned on. But if you wanted to make sure like you wanted to do that by using the T-SQL, you want to turn it on. Alter database scoped configuration, set parameter sensitive optimization to be turned on the database again, right? So you turned it on. Now, did you observe like we need to make sure this database is in the latest compatibility mode, which is 2022 compatibility mode, which is 160. I did that, and the same store procedure that we created before, I'm creating it again here. Same similar kind of store procedure, not exactly, but here I'm selecting from users table where reputation, where I'm searching on the reputation column, right? Order by display name. That is it. I'm executing this. Now, what I'll do is I am going to show you how the column statistics will look like on that particular reputation column because we are searching on the reputation. So let's go ahead and see how the um, column statistics looks like on this particular column, right? So if you observe here, this is a statistic, SQL Server table column level statistic, right? If you know of statistics, you will understand this. So um, a statistic, if you are not much familiar with the SQL Server statistics, apart from just running them, updating them, but not really sure of internal statistics, That's fine. So any like if you have a column inside the tables and you are running the query for the first time using the searching on that particular column, then by default, SQL Server will go ahead and create the column level statistics on that particular column which you are searching. Now, if you already have a column statistic created on that particular column, it will go ahead and use that particular statistic. But as your data is changing, as your data is updating, inserting, we are inserting millions of records every day, then it is really important to update your statistics, right? A statistic is nothing but an internal table that is created by the SQL Server. The maximum number of records that you have is up to 200 rows. That's it. No matter how many records you have, no matter how many billions of records you have, all you get is 200 rows, up to 200 rows, not definitively 200 rows, but up to 200, not more than that, right? So it will describe the distribution of the data within that column. So if you see here, mm, range high key is nothing but the column value. So we are searching on the reputation, right? The reputation column value reputation 1 have the equal number of rows of these many rows. Reputation number 11 have equal number of rows as this one. So like that, if you see the reputation number, this one will have just one row, right? So in that range, how many like this is kind of a distribution of the data. Like there is a whole lot of whole session on it on a statistics column level statistics that I have given in a lot of conferences. You can find that on YouTube. Search by my name, Deepthi Koguri, and statistics. You will find a statistics session. It goes internally into how statistics actually work, what will happen when you update and sort of things. But here you need to know how the distribution of the data is there, right? Mostly um, focus on these both rows. Now, what I did is I checked this table, this statistic, and I have grabbed um, some values, right, which will give me like if you see 5714, so it should be somewhere here 5714. 5714, if you see here, the 5714 have just 8 records, if you see here. Okay. Now the next number is 1. Now 1, which is on the top, have these many records. All right. Now the third one is I'm taking 13. So the 13, if you observe here, range high key 13 should be somewhere here. This one, 13 have 26,955. If you see there are a lot of difference, 10 million, 26,000, and then one row. Now I am like sort of trying to show you how it will actually create multiple execution plans based upon the data, right? If you choose the similar kind of similar number of records as an output, then it might create only one execution plan. So I am choosing different set of values to give me as an output. So I'm executing it for the 3 times because it have to run certain workload to generate those execution plans. So now I'm enabling the actual execution plan, executing it, go to the execution plan and see how it works. Now the first one, which gave only 8 records, 8 records, 8 records, and the second one, if you observe, like it's still running, but the thing is like we have choose 3 different values, 3 running multiple times, right? So the first one, since 8 records, it choose index seek and key lookup. The second one choose in clustered index scan because it is like more than 10 million records, right? And the third one also choose clustered index scan. Now let's see, it executed completely. Now let's run this query to see what's there in my plan cache. This is plan cache. So in my plan cache, we have executed 3 times, and this is the plan handle, right? 2 of them, I think they will be the same. If you see, the last 2 ones have the same no, they are different. They looked similar, but they have a different plan handle. So it created 3 different plans right? And so we have that information here. But by using this particular um, query, which is specially to capture that information from the query store data. So this one shows what is the query text, what is the query hash, and what is the plan hash. Now, if you observe, the query hash is exactly the same because the query is the same. If you observe, that's a single store procedure. So store procedure will have the same exact query hash. Now plan hash is different because it got different plans here. Now if you see, observe properly, these two are the same. So these two are the same, have the same plan hash, but this one is different. So it created two different plans. Now, if you want to see the plans, you can click on them and see. Now, I would like to show how the variant looks like. It's all okay. I would like to run this particular query below to show you how it looks like, how the dispatcher plan actually looks like. Now, this query will show you what is the variant, query variant plan, which is query itself, right? And dispatcher plan. Dispatcher plan will have all the logic, right? Now, I would like to see how it looks like. Now, click on this to see, like it says it contains multiple plans here. This is the logic. It has a logic within itself of which um, where it have to go, like to um, which query? Yeah, this one. So it will show you the logic of to which um, query variant it have to use, which query plan it have to use. Query variant plan is an execution plan. Dispatcher plan will contain the logic in it. So that's how it will work. Now let me go back to my slides again. So let's talk a little bit about memory grant feedback, percentile and persistence and percentile. So before going that, like I promised, I would like to give you as much as possible how the query runs behind the scenes. So we have covered this half of this 1/4 in the query store slide, the flow chart that I have showed you at the beginning of the session. But let's see the any query that is running on the SQL Server, right? It will first go through the transformation phases where it will actually go and do the compilation and optimization phase, and it will actually create the execution plans based upon the cardinality estimates. Cardinality estimates are nothing but the column statistics. It will go like the statistics values that I have shown you, for example, in the previous demo. So it will go ahead and check those statistics of the columns, and it will generate multiple plans. And based upon the cost is nothing but how much of resources it have to use to execute that plan, right? To execute successfully. So based upon cost, whatever cost is low, that particular execution plan will be the winner, and it will be saved inside the plan cache. And as the query goes to the execution phase, that particular plan from the plan cache is captured, and at that particular time, before actually executing it, the memory grant will be actually allocated to that particular plan which you just grabbed from the plan cache, which SQL Server grabbed from the plan cache. It will allocate the memory grant again based upon those cardinality estimates. The cardinality estimates, based upon those cardinality estimates, the execution plan got decided, and then it got saved in the plan cache. Now that execution plan got that memory grant based upon those cardinality estimates, and then the query goes to the execution phase. Now what if this one thing goes wrong here? What if the column level statistics are not properly set or not updated properly, or like you have set the percentage very, very low, which is not beneficial? Now that will actually cause the cost to be set inappropriately, because the cost is depending upon the cardinality estimates, how much of resources have to be allocated to the query based upon these statistics cardinality estimates. So if that cardinality estimates goes bad, cost will go bad, and the wrong plan will be saved in the plan cache, and then wrong memory grant will be allocated for that plan, and query goes into disaster. Like either you'll get the timeouts, or either the query which should execute in 1 second, it will take like 8 9 minutes to run, but it's not good, right? So based upon what? Based upon this particular single thing known as cardinality estimates, which is nothing but the statistics. So why I'm talking about that, right? I'm talking about the cardinality estimates because memory grants are solely based upon those cardinality estimates. And um, if the memory grants are not allocated properly, then what SQL Server does is it won't understand because it is already in the execution phase at that time, and it can't allocate more memory grant on the fly. The memory grants have to be allocated before execution. And again, the memory grants are solely based upon the cardinality estimates. And what can SQL Server do? Poor SQL Server. It will think like I really didn't get what I need. So what I will do is like here I need to process 1 million records, but the memory grant that I got is only for 1,000 records. Like, come on, like the cardinality estimates, the statistics showed me that only 1,000 records will be produced if I run this execution plan. And now when I'm executing it, it is showing me I will get like 1 million records now. Why is that? Is because you did not update your statistics properly. Like DBA did not do his job properly. He did not set the particular percentage properly, and that didn't update the statistics, meaning like SQL Server solely depends upon the statistics. And now SQL Server don't know what to do, so all that it have to do is like go ahead and spill to disk. Now, spilling to disk is nothing but you don't know where to sort the query, sort the results. So it will have to spill to the disk, meaning it will use TempDB. It will go to the it will hit the disk and it will do the sort. And disk accessing disk is like not not a good idea, right? Most of the time we wanted to sort everything in the memory, but anything hitting to the disk is resource consumption, right? It takes more resources. Now your query is running terribly, and and like it runs in 8 minutes, and now that's not good. The query have to run less than in 1 second, all based upon those statistics. So why I'm even talking about this, right? Because memory grants are solely based upon those statistics. So the in SQL Server 2022, the goal is to remove those spills that are happening on the disk, and also to increase the concurrency load. Now, if all the resources are being used by just that one query, now what about the other queries that are waiting, right? So by by having this memory grant feedback in SQL Server 2022, which will take the advantage of query store again. It will take the advantage of query store data to collect that information over time, to set the memory grants properly so that it will actually avoid spilling to the disk. So in SQL Server 2017, we have it on the batch mode. But in SQL Server 2019, we have row mode. But in 2022, these were the updates, like the memory grants are observed over time, the queries are analyzed over time, and memory grants are allocated properly so that it can avoid spilling to disk. So what are main improvements in SQL Server 2022, right? So the persistence is nothing but if I restart the SQL Server, or um, uh, if I have a always on availability group, and if I have to um, move to a different node, then all of that information should be there and it should not be lost, right? So in SQL Server 2022, those are the improvements, that information is not lost, and it is also captured in query store. So previously, before 2022, don't get confused by looking at this diagram. It's very simple. Um, so before 2022, how the memory grant feedback work is, it always just look back the last execution feedback, only the last one. Now let's say the query that you are running actually requires 800 MB of memory to run, right? So that information, like the 800 MB actually it used and it captured that information. Now, next time the query runs with a different parameter, it always looks for the last execution one, right? So the last one is 800 MB it used, but currently it only requires 5 MB. But because it is looking back on just the last one, no matter even if it requires 5 MB, it is still using 800 MB because it is looking back, right? So now what is the problem here, right? Because we are wasting the resources. We just need 5 MB and it is using 800 MB. Come on, many queries are waiting behind, like running simultaneously concurrently, right? We don't want that, but that is what happened with memory grant feedback before 2022. Now, with the memory grant feedback percentile in SQL Server 2022, it won't only look at the last execution, but it will look over time. It will actually look at the history of the execution based upon the query store history data on the database. It will collect that information and it would make sure it will avoid spilling to disk with granting good memory grants over time. Now, previous to SQL Server 2022, now as it was looking at the only the last execution plan, mm, it it used to go overboard, like up, down, because there is no consistency over there, and memory grant feedback used to shut off itself at some point in time before SQL Server 2022. But with SQL Server 2022, that like shutting off this memory grant feedback is very, very low. I'm not saying it's completely zero, but it is very, very low because we are not solely based upon the last execution plan, but we are based upon the history of that information. So it will persist over time. It will persist on failures. It will failovers. Sorry, not failures. Persist on failovers. Persist on restarts, and also the like the plan evictions. So here, if you see, it will find a sweet spot where it will only allocate required memory grant, not more and not less. So it will try to have that balance of like it will act. The goal is to avoid to spilling to this, and when it can avoid is when it will have the proper memory allocated for that query. Let's talk about cardinality estimate feedback. Cardinality estimates we talked a lot about in that previous slide. It's nothing but the column statistics. Very important, very very important. Like the memory, the CPU that it have to allocate to execute your queries are solely based upon these column statistics. And in SQL Server 2022, they used something known as the model name known as related assumptions based upon the history that is captured in the query store. It uses three cardinality estimate techniques known as predicate independence versus correlation. So let's talk about this a little bit, right? Predicate independence. Let's say I'm searching on a query. I'm searching something where I'm searching on two predicates where city Frankfurt and country United States, let's say. Now those two columns where I'm searching on city and country are interrelated, right? They are correlated. Now if the columns that you are searching on are correlated, then the statistics based upon those columns, while it is seeing them in the lens of correlation, it doesn't work properly. The cardinality estimates are not gathered properly. So instead of that, SQL engine will always make that correlation into predicate independence, meaning it will look for those two predicates where it is searching on the city and country, those two as an independent column values, independent predicates, so that it can capture the cardinality estimates properly on those two columns for that particular query. So by default, it will be always pointing back to predicate independence if there is a correlation. That is what it means, right? That is one technique. And the other technique is containment. Containment is nothing but the number of joins you have in your query. So it will based upon the joins, it will also capture the cardinality estimates, which is the statistics again. And the third one is row goal. How many rows it might think it is going to produce. Based upon that, the cardinality estimates are also captured. And this is in SQL Server 2022. So the query, it just don't get identified itself to be in this monitor for the cardinality estimate, but the query has to run certain number of times for it to be mm, actually be identified to be verified. And then once the verification is complete, then the cardinality estimates are properly allocated by using the query store. And sometimes the query, sometimes the SQL engine will also automatically assign the query hinting method to properly use the cardinality estimates. And the cardinality estimate feedback, all you have to do is put your database in the compatibility mode 160. Again, the queries have to be repeated with the persistent plans, right? Um, then only these cardinality estimates will be verified upon the feedback, and then it will go to the implementation phase, and it will always use the query store hints to apply the cardinality estimate feedback. Now, I think this is the last one, DOP feedback. So degree of parallelism feedback is, DOP, right? If your query have to run the parallelly or like single threaded. Now, based upon, again, it will look for the how many times the query have to run, and the queries have to run consistently, not just one time, but the query have to be run continuously, consistently, and then it have to be validated for the DOP feedback. Again, this DOP feedback will use the query store hints to capture the information. So all this DOP feedback does is it will look for a value where the query can execute with a low number of DOP values, with a maxed off value, with a low number of maxed off value up till 2. So it will stop at 2. It won't decrease than 2, but it will always have to use up till 2. So it will, based upon the feedback, it will always make sure to decrease the feedback, not to increase the DOP value, maxed off value, but it will always make sure to decrease that value. And again, is this query eligible? Then it will check, and if the feedback is provided, then the feedback should be validated, and then after being stabilized, then the DOP value will be applied. And I think we covered all of them. So these are my resources and references to know more into like uh, how I prepared this presentation, and like these are the resources and references. If you would like to know more, please look into these resources. And I would like to thank you for your time, and like I hope you learned something new today. And yeah, if